Here's the rotation curve for a spiral galaxy, M31, Rubin, Ford, 1970. In this clip, we'll derive a similar plot using curvature of spacetime as our model. Imagine the Earl of Ross's M51 was to encounter its twin and merge. These two systems have mutual attraction by dint of gravity. They also have substantial spin and are energy systems, like two whirlpools in water or two cyclonic weather masses. So until their energy has been dissipated, they are held at arm's length, bound by gravity, both spinning and both simultaneously proceeding round a common centre. The model of spacetime suggests each individual M51 would distort spacetime in the shape of a bell curve. But, as two systems are crowded together, we might expect our spacetime bell curve to be slightly distorted and the centre of gravity to be shifted towards the common centre. Differentiating this bell curve for dx by dy gives us an indication of orbital velocity for this half system. No surprises here, the velocity tends towards zero at both outer edges and at the centre of gravity. The leftward third is travelling towards us, the rightward 2/3 is travelling away from us. Here the plot's been tapered at either end to indicate that matter is extremely attenuated towards the periphery. Next, consider an already, say, counterclockwise, spinning wheel is held by its axis. If its axis is in turn forced counterclockwise, then the original rate of spin is modified. Using the COG of a single M51 as a datum, the modification would be linear through the centre of gravity and can be added to the initial distance velocity plot. Changing our frame of reference and stepping back from the half system, we now view the entirety from a completely external point of view. Rotating the entire system has the straightforward effect of modifying observed velocities with another linear modifier. This time the value is zero at the system's combined centre of gravity and increasing linearly towards the edge. Here is the new plot for M51, and here is the plot on the same axis for its twin system. The two systems are strongly attracted by gravity, but each has substantial energy and they are kept apart by the differing component velocities at the interface. But the taper introduced earlier into these plots was intended to highlight that matter is extremely diffuse at the individual half system's outer limits. Extremely diffuse matter is unable to withstand gravitational pull, irrespective of conflicting velocities. The two half systems, therefore, are compelled by gravity to merge up to the point where their velocities are compatible, and they have sufficient density of matter to withstand gravity. So the final plot is quite promising. Here's how it compares against a 2017 survey of M33. And here's that rotation curve of M31 from Rubin, Ford, 1970.